because we will do comparison of the cores. We will compare it to the Zen 1, we will compare the architecture to the Zen 2, and we will compare also to the Ice Lake. We will also compare with the Cortex X1. So we have a lot of things. We will compare also the power consumption, some benchmarks. So we will do a lot of interesting stuff here. And Apple is hinting the scenario 3 by their own, because they already revealed this picture. This is their official from the presentation. And yeah, they actually say that they are going to be the average, with the average MacBook, they will outperform most of the desktops. This is really brave statement. But we need to understand how is this possible, because this picture must be actually correct, because Apple announced it publicly, this, and they would otherwise risk really big lawsuit from their shareholders. Okay, let's start with the backwards. Let's start with the conclusion, because I like the numbers, and then we will take a look into some architecture. And yeah, the conclusions are absolutely shocking. My conclusion is that the Apple A14 Firestorm is a really devastating x86 in almost every way. The single thread will be at least 10% higher to the current Intel Comet Lake at 5.3 gigahertz, because Comet Lake can score something like 1400 something. So yeah, so Apple will outperform the Apple iPhone. Actually will outperform the fastest desktop in the single thread. And in the MacBooks and the desktops, iMacs, they can use higher frequency, and they can get up to 18 Geekbench points. This is 20% faster in the single thread. So this is first big issue for the x86. So you can see also, if you take account the Ryzen's, the fastest 16-core Ryzen is providing the Geekbench score around 1360, 5020, depends on the thermal conditions, but it's way slower than the Comet Lake actually in the single thread. So you can see here that even I'm an AMD fan, I'm running right now the Ryzen 3700X. So you can see sadly that for Apple there is no doesn't make sense to replace Intel for AMD, because in the single thread they will actually lose some performance, and actually there will be even bigger gap to their own silicon. The ARMs are really fast, and the biggest problem actually is in a multi-thread, because the ARMs are super efficient. In the multi-thread you are usually kind of limited by the TDP, because the 16-core Ryzens, they cannot run 4.7 gigahertz for all cores. There is only usually one or two cores which can reach this high speed, and the rest of the cores, they are much lower operating frequency. And when you are running all cores, they are running usually below 4 gigahertz. And the advantage of these ARM chips and efficient ARM chips is that they can run all core like for a full frequency. So, and this makes the 50% advantage here. And this is a huge advantage in laptops especially. And you can see here, the predicted Geekbench performance is about 10,000 for the 8-core chip. And depends on the TDP, it could be 12,000. Guys, this is the range where the 10-core Comet Lake is operating, and also the fastest, the Ryzen 12-core Ryzen. 16-core Ryzen is like a 14,000. up to 15,000. So yes, the 8-core chip is really attacking 12-core chips of Intel and AMD. So, and if you also talk, if you take account also the AMD Renoir and the laptop chips, you know, the Renoir is probably the best APU, the best laptop CPU right now, and it scores about 7,000 Geekbench points. So yeah, Renoir will be outperformed by 50% by Apple in-house ARM chips. And this is huge. 50% is really huge. And it might be even more, but I'm using let's say pessimistic or conservative measurements, and this is huge problem for AMD and Intel, and this is the reason why Apple is actually switching to their own silicon. Of course, we will do deep dive into the architecture why, and you will see that Apple, it's not a surprise for CPU enthusiasts. We already, most of them probably know that Apple has a absolutely incredible architecture. Not last year, they are using absolutely monsters architecture since 2017, and nobody else is even close to it. So this is not a surprise for some really informed people. They like the CPU architecture. So, but for most of the people, like me, I was supposed that x86 is the best on the world because nothing else you can buy in the shop. So, but the reality is that x86 is not the best architecture and not the most performant microarchitecture right now. And yeah, and this is only one problem. But the biggest game changer here is the matrix multiplication. And why I'm talking about matrix multiplication? Because it allows 10 times higher floating point performance. This is huge gain. It is much bigger gain than the vector computing, and even more gain because it's actually consuming still the same amount of power. So you are actually increasing the performance while actually not increasing the power, which is a big change in compared to the vector computing, because when you calculate, when you have a wider FPU unit, you actually have a lot of transistors. You go wide, and those transistors do the calculation. Of course, as the SIMD instruction, this is like a single instruction, multiple data. Yeah, you need more transistors, and those transistors, they consume more power. So actually, when you go wide, you actually increasing more performance per clock. Yes, you are increasing also the IPC, but you also increase the power consumption. So you actually don't increase the efficiency much, but this matrix multiplication is actually increasing the power efficiency by factor 10, and this is a huge game changer. This is bigger change than the all vectors computing, and this is coming next year for every smartphone chip in Cortex cores, which is called ARM v9 instruction set, and they are codenamed as a Matterhorn. And why I'm talking about, because Apple is also pushing the matrix multiplication a lot, because when we actually look at the versions of the instruction of the ARM, look at here. ARM is developing the instruction set a lot, and you can see the proposed things. The version 8.6, which was announced last year, and it was pushed by the Apple, there is a one strange instructions, and it is called GEM, which means general matrix multiplication. Apple is pushing matrix multiplication also into normal instruction set as a standard, not only for for the extension for the vectors here, but they are pushing also the matrix multiplication in the standard instruction set. And that's a question if this is going to be like a ARM v9 standard and the chips are coming next year. This is a huge thing, and this is really big change, and this is even bigger than the huge performance that Apple is offering, because this floating point performance will outperform any x86 CPU right now using like a by factor 10.